Associative design is a research program that links a specific design technique to the domain of architectural practice. This design research program applies new computational techniques to the forces of urbanization. Its aim is to construct a population of housing units that together forms a new neighborhood model. Associative design is a parametric design technique using metric parameters to create an infinite number of variations. It is a technique based on associative geometry. Such geometries describe the relationship between various assemblies and constitute a design object as a mutually linked geometrical construction. The term urbanization refers, within this research, to the original meaning given by Seda in 1872 as trying to describe the scientific methodology to construct the growth of cities through the relationship of housing and infrastructure. The form of knowledge produced by the methodology is the idea of types, a form of abstraction that separates the essential from the concrete. This kind of typological thought fitted the normative culture of all bureaucratic and capital structure, and become therefore the only architectural instrument for all kinds of spatial regimes, or what Seda called the 5 laws of urbanization. The technical, the legal, the administration, the economic, and the political, with their forms of expressions like regulations, laws, codes, and policies, and its content, namely the architectural building type. Associative design research proposes an oppositional idea of typological thinking, what in biology is non-population thinking, a design approach of pure variations whereby a group of objects or family of buildings will be differentiated in various degrees and kinds. For the typologist, the type eidos is real and the variation is an illusion, while for the populationist, the type average is an abstraction and only the variation is real. How can we learn from non-planned settlements? What can we learn from emergent urban structures evolve over time without a master plan or any particular authorship? How can we construct the synthetic vernacular? The aim of the research is to project new neighborhood models for Chinese urbanization. The idea is to overcome the homogeneity of social income groups and the sequential forms of ghettoization. The neighborhoods are designed as growth models. These structures are tested by their organizational potential to allow public programs to emerge over time. In order to judge and define the organizational potential of the proposed urban networks, we have used the knowledge of detour systems developed by Frei Otto and Eda Schroer from Iowa Institute at the University of Stuttgart. The research compared a series of planned and non-planned urban fabrics and defined their typological features in order to recognize its potential to adapt to future changes. The research mainly focused on the roles of infrastructural nodes and their connection play in the process of formation of settlement structures. The understanding of these geometrical urban fabrics and the role detour system played in facilitating the settlements are used as guidelines to evaluate our projects. The research is applied on a specific site in Zhujiajiao, within the Yangtze River Delta in the region of Shanghai. Before 1840, all Chinese cities and villages independently of being planned, like in the case of Beijing or through self-evolution as in the case of Yangtze River Delta region, the urban housing environments were based on courtyard typology arranged along land or water infrastructure networks. The courtyards are the private open spaces to the occupants. Traditional courtyard houses had to be transformed due to the radical changes in population growth and social structures. The old-style Shinkumen Linong houses were derived from traditional courtyard residents typically found in the southern part of Yangtze River around 1870. Most of these houses were 2-story high, with a horizontal courtyard in both front and back. The organization of houses was similar to the traditional vernacular. This typology spread later to other open cities along the coast such as Tianjin and Haikou. Around 1910 to 1930, new hybrid typologies between traditional courtyard houses and Western, in this case English row houses, were developed. The main row in the middle of each neighborhood gave the houses access to the urban environment. Until 1990, it is this hybrid that pioneered the city's landscape by providing a continuous field of private housing neighborhoods. Until 1949, the city was characterized by concession zones with various housing developments and an enormous growth of slums around the peripheries. Between 1949 to 1957, the Soviet model was unquestionably introduced. This leads to a new typology, single bedrooms, play along a corridor with shared facilities. The Russians not only introduced a new system of production but also the inner corridor housing plan, a spatial organization which was unfamiliar to the Chinese living conditions at the time. As a reaction, this typology was transformed into a new form of courtyard apartments. This created a hybrid of Russian block with the traditional performance of climate control found in the courtyard houses. Due to the Cultural Revolution between 1966 to 1978, new housing developments were almost in total stagnation. The per capita floor space has decreased from 4.5 square meters per person in 1952 to 3.6 square meters in 1978. In 1984, under the guidance of Deng Xiaoping, the Chinese government decided to move a planned community economy based on public ownership. For the first time, Chinese universities started to perform researches on new housing typologies. Tianjin University performed research on design variations of housing units based on the Dutch principles of SAR developed by John Harbarkan for adaptable housing systems. In order to see the consequence of this policy, 3 pilot neighborhood projects are built in Wuxi, Tianjin, and Jinan. These freestanding housing blocks with large open areas are the prototypes of the current housing developments. The movement indicates the reform in marketized housing system that was no longer solely controlled by the government. Present housing typologies were emerged to suit modes of consumption as specifically focusing on individualization of social group targeted. Homogeneity is the result of standardization within one development. Today, 4 general housing types exist in the market: high-income villa type, row house type, mid-rise 6-story apartment, and high-rise apartment for the high-end users. In opposition to historical research methodologies, in which typological thinking is used to abstract reality, the diversity of Chinese courtyard vernacular is measured by types with specific features. In our research, the goal is to understand the morphogenetic process of production and generation from the vernacular. Our main concern is, what are the forces that drive this diversity? One of the main forces that generates the organizational difference between Chinese courtyard houses is the climatic zone in which they are constructed. Depending on its location and local climate, the courtyard type changes its organizational structure from enclosed landscape composed of freestanding houses in the north to very small light wells in the south. The type's geometry is driven by outdoor spaces for climatic purposes. In the north, the courtyard acts as passive heating device, while in the south it performs as a solar ventilator. The second force of the Chinese vernacular is the social formation of its arrangement. The organization of the residents is in accordance with the degree of publicness to form a pattern with progressive sequence. The courtyard operates as an organizational threshold between the public roads and the private household. Spaces where strangers, acquaintances, guests, and family members gathered for their routines have various degrees of intimacy. Courtyard acts as the public center, embraces the inward complexity of a family, where the composition of rooms is based on the family structure. In terms of its typological features, the repetitive courtyard arrangement becomes the core of the overall organization. As the circumstance of the plot size, the expansion of the courtyard arrangement is longitudinal along north-south axis in accordance with the increasing room number. Independent of their locations, all Chinese courtyard houses are never the same but still belong to one population of houses that have transformed and evolved over time. This type of differentiation is what biologists call population thinking, or the morphogenetic process behind the appearances of all members of a species. What is the architectural knowledge that has been used to produce this diversity? Historically, associative devices do exist in Chinese culture to construct architecture. This model of associativity was especially used for monumental buildings. In the case of palaces, where geometrical construction was based on parameters that depend on the column diameter of one construction component called doko. Similar but less recorded and published in the West are Chinese building techniques used in housing construction. Various structural systems based on associativity depended on local economic status and the level of resources within the region. In Beijing, a system called Tailiangshi, again based on the multiplication of the diameter of the construction column, was used to accommodate the programmatic demand of the courtyard houses. In the canal towns of Jiangnan region, a lightweight structural system called Chuandoujia is often used. The structure is composed of roof purlins, which are directly supported by the columns below. By erasing some of the supportive columns, different programmatic demands might be accomplished by various spatial sizes created. The whole structural grid can readjust itself by combining with systems of Tailiangshi as a hybrid structure. In the formation of a house, the structures are repeated through a room module called Jian, and generated two-dimensional growth in order to accommodate various programmatic, social, economic, and environmental demands. In order to better understand the appearance of the vernacular, we conclude that throughout the evolution of these historic Chinese courtyard houses, their urban appearances and its morphogenetic process have been accommodated by a system of associativity, from the scale of the smallest manufacturing component to the scale of the urban environment. In each scale, new external forces affect the internal constraint of the geometrical model. In the case of Zhujiajiao Canal Town vernacular, the manufacturing process of the roof tiles affects the structural system. The repetition of the courtyard houses is organized along the country's water infrastructure systems, and its variation is articulated differently within each village. Constrained by the geological forces of the river delta, the villages evolve to their final layout of township by their specific economic industries within the networks of canal towns. The knowledge produced by its morphogenetic process is taken as material knowledge on which we have based our projects on. What happened to vernacular building typologies within this period? The organization of the vernacular, the space that once belonged to one large family, was subdivided into small separated units for various residential groups. This has led to building extension that the intended organizational, climatic, and social performances were totally changed. Courtyard houses vanished, and with its associative knowledge from its heritage. In the near future, it is projected that the region of Shanghai will have to accommodate 50 million people by 2050. Therefore, the One City, Nine Towns housing policy is developed for this region by Shanghai Municipality. Zhujiajiao is one of these 9 towns around Shanghai Central District, with its current condition mainly characterized by its historical heritage as one of the preserved canal towns. Developed over hundreds of years, this canal town is slowly being absorbed by Shanghai's new master plan. The new master plan is represented by its infrastructure network and planned for 300,000 residents. It is organized based on the rules of Russian grid and compartmentized into enclosed territorial clusters of housing developments for same income groups within. In opposition to this master plan, we will present models of urbanization that has the capacity to grow and incorporate changes with collective programs over time. The aim is to overcome social homogeneity. We present 4 projects that closely look at specific regimes of urbanization as its driving force and have generated an associative design model. From the scale of housing unit to the scale of neighborhood, each project is constructed as a growth model that can change and adopt over time. We name this approach the construction of synthetic vernacular. Today, China is an overpopulated country with limited land resource to extremity. Therefore, the vernacular organization is no longer function as originally intended. The existing market in Zhujiajiao offers either economical mid-rise development with less living quality or high-standard housing for the higher income groups only. The project aims to achieve the low-rise high-density model with better living quality for different income groups. Referencing the Chinese living culture and climatic performance, the north-south typology is the most popular one in the market. This geometric model provides longer south-facing width and natural ventilation from different orientations and tries to overcome the existing rectangular model. The inner corner of the L shape can be the private courtyard, while the outer corner becomes part of the shared collective space. The courtyard is formulated by putting several units in a plot. Generated by 2 identical rectangles, the plot transformed from pentagon to quadrilateral contains minimum 1 or generally 2 right angles, which are preferred to both construction and housing organization. By varying the size and configuration of the plot, the number of the neighbors sharing the same collective courtyard and the organization of the housing unit changes. Different FAR value and population density are created. The housing unit varies both in size and angle, therefore can accommodate different family structures, from single-person accommodation, nuclear family, to extended family, and offers various organizations for different income groups and individual preferences. The floor plan of the lower level gives the basis for growth above. At the same time, it creates upper courtyards and different routines for each apartment, which is different from the existing staircase home linkage. The courtyards act as the transition between private and public, therefore the street courtyard home routine is three-dimensionally created. The national regulation of providing 2 hours sunlight for each apartment in the specific day in winter is integrated in the geometric model. Certain distance and number of floors are automatically calculated. Associative design is known as a high-tech approach. This project aims to apply this high-tech approach in China's low-tech construction situation. This means only identical component is prefabricated and adjustment is done manually, which is economically feasible in the local condition. This geometric model shows how identical components are linked together by adjustable component, therefore it follows any curvature and offers different openings. Sun as the main environmental concern is considered through 3 aspects: incident energy, shading, and daylight factors. Incident energy is the technique to measure the insolation. It relates to 2 values: the sine of sun altitude angle and the projection area. The incident energy of a surface is calculated according to different orientation and tilted angle. To maximize the solar gain in winter and optimize the solar protection in summer, a particular angle is calculated from the comparison graph. The result curve shows the best tilted angle for each orientation. According to the daylight factor graph, each function of apartment requires different sunlight condition, which determine the opening of the component. According to the temperature graph of Shanghai, from May to September, shading is required. Each wall is the result of negotiation to these 3 factors. When the opening is wider, the shading factor is more influential, therefore the tilted angle is getting smaller, and vice versa. Therefore, each wall is differentiated in accordance to its orientation and function behind it. A geometric principle of junction making, detour system, and the relationship between junctions and activities are considered. By assembling several plots together, different junction configurations emerged. Different boundary conditions and configuration of the junctions formulated by outer corners of the housing units are suitable for different activities. The cantilevers of the units generates comfortable spaces which are exposed to the sun in winter but provide shading below in summer. This feature is particularly favorable in Shanghai's humid weather. These below spaces allow outdoor activities to happen in the rainy season. A series of courtyards with different degree of intimacy are created and therefore offers various spaces for different people and activities. Some upper courtyards can be shared by different families and therefore change the configuration of a relationship between families in different plots. The collective courtyards vary in size and configuration, can accommodate different outdoor programs. The ancient canal towns are unique of their non-planned self-organizing nature based on the needed economic activities. This is unlike other Chinese cities where the formality and sizes are reflected by regulated planning. The existing master plan is based on subdivision according to the national regulation, and each subdivision area offers 1 housing type towards a similar income group. In long term, this kind of development occupies massive land in a short span of time, which is not suitable for sustainable growth. The intention of this project is to challenge the existing model by providing a wide range of housing types within the same development to achieve the social diversity intended. Following the economic principle, 2 driving factors of land evaluation are considered to differentiate the site in this scale: the noise and water landscape value. A 10x10 grid is positioned on site. Each intersection point needed to be calculated according to the graph of sound power level and the distance towards the water based on the river width. As a result, the outcome points are differentiated depending on the position it is located. A land value map is generated. Each gradient of grade relates to different FAR value, income group, family structure, housing arrangement, and numbers of neighbors. By applying the housing plot on site, This geometrical model shows how new plots are generated out of the existing ones. 3 existing site conditions are considered: angles less than 90 degrees, between 90 to 150, and finally between 150 to 180 degrees. 2 things are considered: the size of the polygon, which relates to the FAR value, population density and income group, as well as the orientation for each side in order to make sure that each apartment receives sufficient sunlight. Different simple strategies in accordance with the land value map are applied in order to generate the proper size and orientation of polygons to fulfill the economic requirements. As a scenario, the first growth completed when it contained approximately 600 people and 200 families according to the national regulation to the cluster scale. With the integration of water, car access roads, and pedestrian paths into the unit, the network of the path system and junctions are emerged and evaluated. The values are decided by the evaluation adjusted through the Excel sheets. Integration, which is used to estimate the frequency of use, mainly the pedestrian flow, has been calculated. Therefore, the width of the pedestrian and formation of the junction is determined. Parking is calculated to 0.6 to 1 car per family according to the plot size and housing standard located on the ground floor. To minimize walking distance, every unit has at least one side for parking, and this formulates the driveway. Different communal functions are placed to the most frequently used path according to the character of the path and the junction, and water is placed beside it to enforce the recognizability. The most accessible plot within the cluster becomes public space. According to the economic principle, the most popular path from the existing cluster will affect the land value. Therefore, the next stage of growth will be based on the new land value map. According to the size of the site and population, 6 steps of growth are taken. The final result consists of parking system, pedestrian network, water system, public spaces, and program distribution. This comparison shows the result of the FAR value of each plot has fulfilled the land value's requirements. The geometrical properties of network is considered in 2 aspects: the number of average node type and average neighborhood. The result shows the network has similar topological properties with all the non-plane settlements studied from Phi Alto that in comparison different from either various kinds of homogeneous grids or branch path system. What can we learn from the Chinese vernacular? Today, China's vast urban development is witness of its succession in the nation's economy. To accommodate this rapid growth, the market offers building typologies in repetition, a way in which standardization is purely economically driven and offers no diversity within one development. Evidently, in the building environment where comfort was relied on natural mechanism originally, is now supported by less sustainable energy-consuming equipments. The project aims to start with this missing link by re-examining the role of courtyards from the vernacular to avoid centralized extension that happened to the existing. What used to be the central feature of a house is now located on the building edge. The courtyard have the dual potential to be both private and public, allowing units to multiply one beside another, generating open spaces in between the building footprints as infrastructure or landscape. Geographically, the project is located in the alluvial plain of Yangtze River Delta, where water is common in everyday life. The relationship between water and land is examined. Environmentally, due to their different thermal behaviors, the two obtain different surface temperatures throughout the day. This temperature difference allows natural airflow to occur between these two counterparts. In the Chinese vernacular, a ratio is given between courtyards in one house to activate the same mechanism. The difference in surface temperature is a result of different courtyard sizes and their locations that verifies the different degree of sun exposures. This is particularly favorable in summer when temperature is high and the air is still. The mechanism ensures to bring cooler air into the house both day and night. Consequently, in the unit scale application, the difference in courtyard sizes generates variation in the housing plans. Rectangular unit footprint is the result of this geometrical model. Depending on the width and length ratio of a unit and its constraint to the internal layout concerning ventilation, the elongated shape with its corridor typology is chosen as communal accommodation targeted for young urban migrants, while the squarish formation with its centralized quality is more suitable to family organization. It is regulated in housing environment. Each functional area has a given percentage of wall openings. The living room standard is chosen for the maximal requirement, calculated an opening ratio of 15% to the total floor area for this model. When assembled, individual units can merge together, optimizing building envelope to achieve the optimal 15% opening surface ratio. This operation allows a maximum of 4 units joining together sharing one internal courtyard. These variables in unit layout facilitates different social interaction through courtyard distribution with surrounding units. When dealing with the level of intimacy as well as the thermal comfort, the degree of difference is reflected by its facade element. All components have the same volume. In private zone where intimacy is required, the number of U-shaped components increases. As a result, the components act as vertical shading device, resulting deeper recess which permits less visibility and some penetration to the interior, but its thickness acts as the thermal mass of the house. In communal area where sunlight entry is preferred, the U-shaped components are wider but thinner, with larger openings for better sun penetration and visibility between inside and outside. Two means are essential to the construction of the cluster. First, the area ratio between the housing unit and its void components. Second, the size ratio between the small and large voids. When assembled, the voids can be either enclosed as private courtyards, shared between units, or opened for public access. This generates variation in the cluster model. Cluster with all courtyards enclosed, half enclosed and half opened, or fully opened to accommodate different social and environmental qualities. The standard unit of 90 square meters is used to accommodate Chinese market standard and the minimum cluster size achievable. The sizes, which are generated by different wall ratio of the starting units, are also determined by environmental boundaries on site. Two parameters are used to control the growth on site. First, the size of the cluster is directly related to the wet and dry boundaries established from the existing canals. On a given size of land, a field of smaller clusters generates longer parameters in total for waterways in comparison with the larger ones. As a result, smaller clusters are populated on wetland and larger ones vice versa. With the environmental intention, the larger open landscape in between and within the clusters have the potential to facilitate excess water in the flood season if required. Each growth is generated by its adjacent neighboring clusters depending on the degree of water containment it is located. The second constraint, generated by the pavilion winds, is operating the phi factor. To block the cold winter front from northwest direction, the roof plant is the highest on this corner. The building height line is then trimmed towards the southeast edge to maximize wind penetration in summer when the climate is hot and humid. The same principle also applies to the unit roof to identify the location of the highest pitch point in the roof profile. Parabolic curvature is applied to generate roof surface in direction facing the monsoon season. An idea which is adopted from the vernacular is to shed the surface water off more efficiently while still provide shelter from the northwesterly. In each stage of the growth process, the initiating water content is the only known feature. A minimum of 10 to 15% water coverage is required in this region for flood control. To complete this neighborhood model, 3 networks are considered. This includes road infrastructure, water infrastructure, and landscape element that transits between the wet and dry territories. The wider the width between the cluster formations, more possible layers of networks can be implanted into the system. Taking the canals as the boundaries, vehicle access roads are firstly evaluated through the hierarchy of number of intersection nodes for the 3 sectors. To minimize coverage for vehicle roads in each sector as independent traffic loops, secondary detours are integrated into the network for connectivity and distribution. Free open spaces are meant to terracing landscape, designed purposefully for water infiltration, an environmental device to collect not only the storm water, but also transform as the extension of a river valley in the flood season. The resulting landscape constantly changes in accordance to its environment, accommodating different seasonal social programs. For pedestrian network, bridges are interlinking the sectors approximately every 65 meters to maximize communication within the neighborhood. All crossings of these 3 networks have the potential to accommodate or initiate uses other than residential, depending on the network combinations and their locations. Focusing towards social diversity and environmental sustainability as intended, the evaluated vernacular forces are integrated into the unit arrangement to the overall neighborhood scale. From the concept of privatized courtyard to public infrastructure and landscape, the quality of vernacular is synthesized and reinstated in this low-rise, high-density development. The ambiguity of vernacular voice spaces, which appear either internally as courtyard typology or externally as linear street formation, has generated a fascinating living experience. Around 1900, the arrival of foreign capitalism brought a dramatic social change in Shanghai. A new kind of neighborhood structure called Linong emerged. Again, the organization of Linong neighborhood has generated a hierarchical layout, where voice spaces as powerful container triggers the emergence of all kinds of activities and encounter of all people. The intention of this project is to learn from the spatial organization of the vernacular models, aiming at exploring possible model of modern Chinese living quality and offering alternative strategy for middle-income people. The current housing market delivers an effective typology following a sophisticated logic of room arrangements. The analysis of 90 square meter standard plans suggests the potential in the core living area where a voice space can emerge. A private skywell performs better for lighting and ventilation. More importantly, its spatial quality creates a modern way of Chinese living. However, the formal unit varies. The skywell is in between the active living space and still zone, generating a rich package of room arrangements. Rules are set with the constraints of the staircase to ensure the homogeneous quality to all the skywells. Skywell in each floor negotiates with each other to give spaces to one above or below. This results in a semi-exterior space individually and together forming a three-dimensional void space. Multiple options can be offered to people with different social status and preferences. In the vernacular, brick is the main construction material. To provide the maximum privacy for housing units and to ensure the environmental performance, a facade made of cold brick is proposed. Each brick with specific orientation reacts on its position within the facade and on the sides of the courtyard with horizontal rotation and offset to the next brick. Therefore, the views from inside and outside could be precisely restricted and at the same time guarantee sun shading in summer, sunlight entrance in winter, and cross-ventilation in all seasons. A public courtyard can be created by the composition of two pairs of units. The dimension of the courtyard is defined by sun regulations and perception of the space itself. By shifting the position of the housing units, the amount of entrances and density varies. The characteristics of the courtyard is generated by the containing components. The repetition of courtyards results in different junctions and street patterns. These patterns can be specified through local controls on road bifurcations and exits, therefore creating a certain depth, which defines accessibility and collectiveness. According to the Chinese housing regulation, one of the main forces driving the planning is the distribution of programs. In opposition to the existing top-down assignment, a program-guided system is established. Each program requires particular conditions in terms of land use, ground areas, location, and preferences due to the domestic behaviors. Therefore, the sizes of courtyard always adapt to accommodate different programs. As the amount of housing units increases, new programs emerged to meet the local demands. Once the service radius reaches its limit, a local center is formed and then comes a new population. After the second local center is also recognized, commercial programs appear in between and turn into the new center of gravity. The further the growth continues, the more complex the hierarchy of program centrality gets. The occupation on site is the application following the logic of programming regarding the ground condition. The morphological process performs in an associative relationship with one affecting the other. Infrastructure appears after a certain depth is created. It provides a basis upon which programs in different domains and locations can be created and set up to reinforce the vividness of living environment. The master plan comes out as a result of negotiation between environmental, political, social, and economical factors. The new neighborhood is decentralized into a mass of islands divided by canals. Entrances to the neighborhood and the width of motorway are restricted to the minimal, encouraging the pedestrian quality internally. The infrastructural configuration of the neighborhood displays a network of different degree of intimacy. The programmatic use of public spaces reflects similar performance as the Linong neighborhood does. Road linkage to all islands are mostly occupied by the intersocial programs such as retail facilities. Communal facilities process the main crossing, encouraging a dynamic population flow. Secondary road junctions with concentrated population flow, and at the end of the branches, only closed neighborhood occurs. The street patterns turn out to be a mixture of configurational properties of moderate connectivity. It is neither like a typical modern suburban layout, loop roads with tree-like configuration of low connectivity, nor like a traditional grid network, which has regular orthogonal rectilinear street with high connectivity of crossroads. The frequency of the T-ratio and X-ratio, as well as the diversity in junction types, ensure an efficient circulation system without losing the hierarchical accessibility, producing the ambiguous perception and a sense of security like the vernacular does. The evaluation of all the clusters display a complexity the system generates. The richness of the neighborhood model is proved to be able to offer various options for the wide range of targeted groups. In traditional Chinese culture, courtyard, which embodies the centrality of housing organization, is one space to tie the family together. Nowadays, in the emergent cities of China, following changes in family structures, the original meaning of courtyard was missing. The intention of this project is to reintroduce the idea of the courtyard into contemporary housing production. In Chinese society, eating culture plays an important role for Chinese people. Therefore, the central hall consists of dining and living spaces becomes a considerable focus of the house. In order to create the central hall within the housing unit, while keeping the characteristics of the space, the shape of the living dining room can be deformed around the three axes to maximize its flexibility to accommodate different household compositions. Referencing the existing housing market, the available sizes of residential housing units are determined by different income groups and their demand for floor area. Higher income group acquires more floor area. On the other hand, this diverse unit also offers some floor area, but different living life qualities for nuclear family, multifamily, dormitory, or Soho housing unit. By rotating the direction of housing units on each floor, it purposely produces multiple open spaces in the junctions of the fabric structure. This newly generated multiple-choice combination acts upon the private courtyard as balcony or garden, as entrance or crossing path, which further extended the centrality of the housing units. The local inclination of unit facade is suggested by solar azimuth in order to acquire the optimal radiation. The facade is generated by different pitch sections due to its orientation. The envelope, while providing sufficient shading, suggests a differentiated level of intimacy which arises between the internal planning of the units and outdoor courtyard spaces. The openings of the shading device are calculated to shade either one single or multiple units. Housing units, as skeletal components, are constituted to generate diverse morphological transformation of courtyard spaces and to assemble various collective courtyards. Furthermore, it drives the interaction between inside and outside, public and private. The local policy determines the occupation of functions, which include education, commercial, and road system. The collectiveness is through the progress when principal requirement of each primary function, such as accessibility and security, is combined. The series of intermediate programs emerge to interlink housing clusters with relevant function needed for communication within. Housing units are organized with a collective courtyard, which varies in size and shapes to address different programs that provide a range of social interactions. The accessibility of each exclusive courtyard depends on its inner programs and functions of surrounding housing units. Courtyards with multiple communal functions starts the cluster. The gradual effect of the clustering exists in the allocation of several different neighboring programs, which creates linear, centralized, or scattered layout. They generate various newly functioned, articulating housing units, which have different contribution to public interaction in the local community. Taking Zhujiajiao as the reference, the program appeared from infrastructure and local demand. The growing zone gradually progressed from an interaction point on site, following the sequence of commercial, educational, and communal use. Furthermore, the urban fabric is extended, containing more multifunctional communities. The expansion of the cluster initiates with homogeneous housing units with attached courtyard space that is controlled by environmental condition, providing a non-diversified living condition for the inhabitants. The process proceeds by units proliferation, when the units embedded into the site, connecting to its neighbors. As the population reaches a specific number, the program emerges out of homogeneous cluster. The road was opened for accessibility and public use, such as shopping street or parking lots, for visitors and service use. Private pedestrian access is also provided, allowing a fluent conjunction through the neighborhood by its communal open space. According to this regime, which embodied in the organization itself, are four crucial programs preceded by the requirements. First, the shopping function creates a linear street and links to the main infrastructure. The office zone disposes an open road to the public, servicing parking lots for visitors and also inhabitants. The recreational zone is composed with natural field and multifunctional structure such as exhibition hall, library, gymnasium, park, or sports field. The kindergarten provides a safety area for children and links to its neighbor for security concern. As a result, the cluster are unfolded into the site, forming the new neighborhood model. Collective courtyards generated by various housing quantity. The essential quality of the courtyard is determined by the reciprocity among the neighbors in terms of programs, how it generates continuous routes to connect each housing cluster, not only to access from the external entrance, but also in accordance with the program. The individual housing units links to specific outdoor spaces in the neighborhood for better communication and participation. In opposition to conventional planning, each of these research projects can be understood as a top-bottom approach. This means that each project is constructed by very precise and specific rules and constraints. If it is applied in practice, it allows for emergent effects, since all models are growth-based, and even more important, generate high degree of connective urban fabrics. These urban fabrics are historically recognized as organizations that can incorporate changes. It behaves not on the premises of a perceived idea, but as an evolving environment.